guys. So that's another complex analysis video, and this one is very elementary, but still can be should be investigated. Okay. Okay. So let's talk about two methods. Okay. So the first method should be direct computation. So let's maybe do this. Why I say direct computation method should work because this is this polynomial, right? So the standard calculation that I would let x to be tangent theta, and so x squared plus 1 will be secant squared, and the dx will be dx will what will be so the differential about tangent will be secant squared d theta, right? So this original integral can be from 0 to pi over 2. 1 divided by secant to the fourth and secant squared d theta. So this is 0 pi over 2 cosine squared d theta. And this is very easy, right? Since one can write cosine as 1 plus cosine 2 theta, and the cosine 2 theta integral power will be 0. So let's write down theta divided by 2 plus 4 sine 2 theta pi over 2 and 0. So if you put pi over 2, you get pi over 4, and sine pi is 0. When you put 0, you get 0. Okay, so the answer will be pi over 4. Yeah, so this is the direct computation. Let's talk about a second. By the way, hope you guys must hope you guys subscribe to my channel. Okay, and click the notification button, and also click the like button and leave the comment. You can leave whatever you want, basically whatever you learn, or you think this is too easy. Yeah, you can tell me. And the next is we talk about a complex integration. So let's do it quickly. So the complex calculation is that you choose a contour like this, right? But the idea is that your function f of z should be 1 over z squared plus 1, z squared plus 1 squared, and they're the only point here, right? So so you choose a calculation. So you know this part plus this part. Let's say this is 1 and 2. You get a 1f integral plus 2f integral will give you 0. Will give you the 2 pi I. The residue, only residue equals to I, right? So d squared plus 1 squared. Okay, if you take the radius to be infinity, then your first part, right? Your r part will be 0, right? Because this is c to the fourth, and the dz only give you 1, right? So this is 0. So when r goes to infinity, this second be 0. So you only the 1 is just what you want, right? But the times 2, because this is a even function, so it becomes 2 pi I residue z equals to I z squared plus 1 squared. Okay, so let's write down. So everything we have is this equals to pi I residue z equals to I 1 over z squared plus 1 squared. Okay, and finally this can be computed, right? Remember that so this is a z plus I, z minus I. So this is a second order, right? So by the residue formula, we need to times z minus I squared to cancel the pole, right? To cancel the pole and do the differentiation, and put z equals to I. Okay. So this is a pi I, and the differentiation is right. So if you cancel all the pole, you get this, right? So z equals to I. Then this is just pi I differentiation respect to z, right? So we get this, and then we plug z equals to I. So this is negative 2 pi I, and there is 2i to the cube. So it's minus 2 pi I, 8 minus I, right? So the answer will be pi divided by 4. Yeah, so if you use the so-called if you use a complex analysis, and you still get the same answer at pi over 4, right? As we use the standard, as we use the direct computation, we also get pi over 4. Let me provide another detail that why why 2 will be 0 when r goes to infinity. Okay, so this is the common that I want to say. So the idea is that if you choose a radius r, right? So we want to prove that this part 1, this part f or maybe I use 2, f of z dz will be 0, right? As r goes to infinity. So that means that our calculation, let's say z should be r exponential I theta, right? So our answer, this is our form, right? So the key is that if we take the absolute value, then this term will less than the absolute value of f of z dz. Okay, so this is less than the absolute value of z square dz, right? So yeah. Okay, so now see, we can put our form. Z is r exponential I theta, and this is less or equal to z to the fourth, right? Because I can cancel this, take the absolute value, and the dz is just r exponential I theta I d theta, and the 0 to 2 pi, right? And the z is also the radius r to the fourth, right? So r to the fourth. So this is 0 to pi 1 over r cubed d theta, right? Because exponential I theta and I can be their magnitude is 1. So it becomes 0 as r goes to infinity, right? Because this is just 2 pi. Okay, so we proved that this guy is less or equal to 2 pi divided by r cubed. So it goes to 0 as r goes to infinity. Okay, so yeah, this is a good example why we can get the same answer since that yeah, becomes 0. Okay, so yeah, this is a fairly easy example. See you guys next videos.